So, quick progress report on the Hallmark impact tolerant touch probe. It's going really well. The early adopters all seem to be happy. I haven't had any bad news back, and my in-house testing is still going well. So it's been a few months now where it's been running rock solid. And as mentioned in my last video on the subject, I'm sure some of you are thinking, why are you not selling these now? Well, what I'm testing for is long-term reliability, because specifically low-cost touch probes are notorious for poor long-term reliability. And I've heard back via email and comments from lots of users that have bought low-cost touch probes, and they just haven't turned out to be reliable long-term, and they're just stuck in a drawer somewhere and not being used. And so I'm trying to break that mold and come up with a really reliable, user-serviceable, long-term reliable touch probe. And the only way I can see to be sure that I've got that is to do long-term beta testing. I don't want to sell hundreds of these probes only to find out that I've got a major support nightmare on my hands, sending out parts to a large number of sales to say, well, actually you need to replace this part internally with this component. It would just be a logistic nightmare. I really believe in backing and supporting the products that I'm selling here, and so I want to keep the exposure small initially. So how long do you beta test something for long-term reliability? 3 months? Well, we've got there. 6 months? 9 months? I'm not sure. The more months that go by, the more confident I am that we have got a long-term reliable product here. Thanks for your patience, guys. If you're interested in the probe and you haven't heard about it before, have a look at my part 6 video on the subject, and at the end of that video I go into contact details if you want to get hold of me. So what I'm currently doing is a second production run, a bigger production run of components. I'm still running my engineering, parts and tool making business, and in between jobs and when I'm quiet, building up stock of parts. Alright guys, thanks for your patience. Most probes don't have securely mechanically connected probe tips, but they're just cemented on with epoxy and so on. But with the Hallmark impact tolerant touch probe, it needs to be really strong so that it can stand impact without the tip breaking off. If you look at a Hallmark tip, it's got a fragile, self-sacrificing tip on the stylus, and it looks like it's just cemented on with a little cup-shaped flange, and that's adequate because it's self-sacrificing and you have that ceramic section which will break away on impact. But with the Hallmark impact tolerant touch probe, it's designed to be stiff and strong, and so we've got a spark eroded hole deep into the ball and a high tensile stylus spigot goes deep inside there, made out of hardened H13 steel, so that is really bulletproof. It can stand severe impact. Oh, that's just the finishing electrode to do the final sizing of the little pocket for the spigot. It's always fun trying to improve production efficiency. Here I'm spark eroding the holes in the little stylus balls. So there's tiny little vent holes through the electrode to let the gas out. You can see it there, coming out through the electrode. So we're just burning down these stylus spigot holes, almost 3 millimeters deep, to provide a really secure mechanical connection between the stylus and the tip. Hollow bearing balls. It's a bit tricky to film, they're so tiny, but they look pretty cool. So the balls are all conveniently at a 4mm pitch, which makes it easy to set the position of the electrode with the DRO, and they can all be clamped together because there's a strip of aluminium down the side which allows the small indentation of that aluminium to put a clamp on all of the balls, and they're sitting on a parallel, so the depths of the little pockets can all be the same. Here we are, find the middle of the work, set work origin. So this probing routine just establishes the size of the work and then goes around and does an accurate probe and sets the work origin for the X and the Y. Then I can set the Z if you're American, or the Z if you live elsewhere. Probe Z, set work origin. And now we have that set. So if you are interested in this probe and you haven't seen it before, have a look at the last video specifically on that subject, which is part 6, and at the end of the video there's some contact details if you want to get hold of me. Thanks guys.